Hi everyone, it's Mrs. Bebo. In this video, we're going to take a look at dimensional analysis. So for my students, this is a continuation of lesson 2.7. For others, this might be a completely different unit or different lesson within your curriculum. So our main goal for this video is how do I convert units using dimensional analysis? Dimensional analysis is the process of performing operations with units. It's also known as unit analysis. Basically, we're going to be doing a lot of conversions between units. In our first example in this video, we're going to take a look at the one on the left. It says Mark is purchasing an above-ground swimming pool. The salesperson says that the pool will hold 97,285 liters of water. If 1 gallon is equal to 3 and 785 thousandths liters, determine approximately how many gallons of water Mark's pool will hold. So to get started, we're going to write down the initial information that they tell us, which is that the pool is holding 97,285 liters. And we're going to just put that over 1 because essentially we're setting up what are looking like a lot of fractions so that we can cross-cancel those units. So this conversion factor that they give us, the fact that 1 gallon is equal to 3 and 785 thousandths liters, we want liters to cancel out. So this 3 and 785 thousandths liters is going to go on the bottom where 1 gallon's on the top. So liters will cancel out and I'm left with a label of just gallons, and we want to know approximately how many gallons of water the pool's going to hold, so this is perfect. So now all I have to do is multiply this out. Well, 97,285 times 1 is just 97,285. We're going to have that 3 and 785 thousandths on the bottom. And then dividing this out, we get approximately, because it does say like we're going to round, right? When it says approximately, that's your indicator to round. We're going to get approximately 25,703 gallons. And that's all we had to do on that question. So we just had to pay attention to the conversion factor that they gave us, make sure we're multiplying it in the correct order so that the labels will cancel out the ones that we don't want to have it end up in, and we end up with our answer here. So now we're going to do the same thing for converting these distances. So we're going to find the length of each distance to the nearest hundredth of a mile. I have some common conversions at the bottom here. One that we might want to add that I didn't put on here is the fact that 1 mile is approximately 1,609 meters. All right, so going back to part A, we're going to convert 4,000 yards into miles. So just like the previous question, write down what you're starting with. So in this case, the 4,000 yards, I'm going to write it over 1, and then we're multiplying by, well, taking a look at some of our factors down here. Again, our goal is to get to miles. So we can use the fact that there's 1 and 94 hundredths yards per 1 meter. So we're going to put meters on the top, so 1 meter over 1 and 94 hundredths yards. Because what's going to happen is the yards would cancel out, right? Yards, yards, they cross cancel. Continuing forward, we're going to want to convert our meters into miles. And so knowing that there's 1,609 meters per 1 mile, we can then go through and do that. So multiplying across the top, let me go back and show that the meters cancel out. So meters cancel out, we're left with just miles as our label. 4,000 times 1 is just 4,000. We're going to have that 1 and 94 hundredths times 1,609, and we get 1,760 and 246. Oops, let me rewrite that because that got kind of messy there. So we get 1,760 and 246 thousandths. And then we're going to divide. So we're going to do the 4,000 divided by that 1,760 and 246 thousandths. And we get approximately, and we're going to round to the nearest hundredth it says, so we get approximately 2 and 27 hundredths miles. So that'll be my answer for part A on this question. 2 and 27 hundredths miles. So moving into the next one, right, we're going to convert 200 meters to miles. So like I said on the previous question, I would start off by writing out your initial value. So 200 meters, write it over 1. And we're going to be multiplying by the fact that there are approximately 1,609 meters in 1 mile. And basically what happens here, again, meters are going to cancel out. We're left with just miles. We're going to do that 200 divided by 1,609 because when I multiply across the top and multiply across the bottom, that's what I end up with, right? 200 over 1,609. And when I divide that, it could approximately equal the 0 and 12 hundredths miles. And so that's my conversion on part B for this question. And then for the last one, if you're not a runner who knows what 5 kilometers is approximately equal to in terms of miles, we're going to put 5 kilometers over 1. We're going to multiply by the fact that there are 1,000 meters in 1 kilometer. We know there are approximately 1,609 meters in 1 mile. So multiplying across the top, we'll have 5,000 over the 1,609. And then when I divide that out, I get approximately 3 and 1100 miles. And that's my conversion there. So essentially, when we set up these questions, you're using those conversion factors to cancel out the unit that we don't want. So like on this last one, I didn't show that, but essentially our kilometers cancel, the meters cancel out, right? They cross cancel, and you're left with the label that you are looking for. So that's part of this dimensional analysis. So let's take a look at another example. So in these examples here, we're going to be doing the same thing where we use dimensional analysis to convert units. Up here at the top, I have some of our common conversions that we might want to make a note of. And in this first one at the top, it says a recipe calls for 20 fluid ounces of milk. If Nita buys a half gallon of milk, how many batches of that recipe can she make? And they do give us a hint that 8 fluid ounces is 1 cup. So I have that over here along with some other information that we're going to need for this question. So we're going to take the total amount of milk, we're going to convert it to quarts, then to pints, then to cups, and then finally to the number of ounces so that we can go through and figure out how many batches we need to make. Writing this out, the amount of milk that we have right now is a half gallon. So we're going to start off this question by writing a half over 1, half gallon over 1. We're then going to multiply by the conversion factor for quarts to gallons. So we have 4 quarts in 1 gallon. And then for quarts to pints, because again, we want to cancel out quarts, in 1 quart, there are 2 pints. And then for cups to pints, there are 2 cups in 1 pint. And then finally, we have the fact that there are 8 ounces in 1 cup. So just to make sure that we set this up correctly, our labels should cancel out. So gallons and gallons would cross cancel, quarts and quarts, pints and pints, cups and cups, and we're left with just ounces, which is perfect because that's exactly what we want. So essentially, we're just going to go through and multiply a half times 4 times 2 times 2 times 8, and we end up with 64, and we could put fluid ounces in this case, or just ounces. There is a technical difference, but in this problem, it's not a huge deal if you just put ounces. So 64 fluid ounces. And now we're going to go through and figure out, well, how many batches can we make? So if each batch can make 20 fluid ounces, or uses, 20 fluid ounces of milk, we're going to take our answer of 64, we're going to divide it by 20, and we're going to find that that's equal to 3.2 batches, 3 2/10 batches. Well, we can't really do 2/10 of a batch, so we're going to say this is approximately 3 batches. That'll be it for that question. On the last example that we're seeing on this page, it says a fisheye lens for a camera has a minimum focus range of 13.5 centimeters. If 1 centimeter is about 39/100 inch, what is the minimum focus range of the lens to the nearest thousandth of a foot? So, setting this up, again, we're going to start with the number that they tell us, which is the 13.5 centimeters. I'm going to write that over 1. And then we're going to use that conversion factor they give us, which is the fact that there's 39/100ths of an inch in 1 centimeter. And then we all know that in 1 foot, there are 12 inches. So that's the conversion factors that we're going to use. And again, with our dimensional analysis, what happens is our labels will cross cancel, which they do in this case. We're left with just feet, which is perfect because that's exactly what we want when we go through and multiply this out. When you multiply across the top, we're going to get 5 and 265 thousandths over 12. And then we would divide that out and round into the nearest thousandth, so that's 3 decimal places. We'll get 0.439 feet is our label. So 439 thousandths of a foot is going to be our final answer for this second part. Okay, we got one more example in this video on dimensional analysis. And in this one, it says Carla is reading a story from 19th century Japan for her literature class. In the novel, the main character, a.k.a. can run long distances at 16.5, and I'm going to apologize if I butcher this, Kanajuku per second. So Carla knows that the Olympic record for running a marathon distance of 26 and 2/10 miles is about 126.5 minutes. She wonders if a.k.a. could beat that record. So they tell us, again, what that distance is equal to in meters. And And we're going to find out how far that this person could run in miles in that amount of time and basically see if this person could beat that record. They also give us a hint that 1 mile is approximately 1,609 and 334 thousandths meters. As a runner, we really don't care about that 334 thousandths, and I'm going to tell all my students you can completely ignore that piece. So don't make it more complicated. 1 mile is approximately 1,609 meters. That's it. So going back to this question, there's actually going to be 2 steps that we have to take before we can compare whether or not a.k.a. can beat the Olympic time, right? And even run that distance in that time. So the first thing we're going to do, so step 1, we're going to convert the distance that they give us into miles, right? Because right now they're telling us that he's running a marathon, so 26 2/10 miles, 26.2 miles. We're going to see what distance he's running and comparing that to this 26.2 miles for this time. So we're going to convert distance to miles. So starting with the 16.5, Kanejiku, probably butchering that, I apologize. So I'm going to abbreviate that though as kj, so 16.5 kj over 1, and then we're going to use that conversion factor they tell us, which is the 10/33 meters over the 1 kj, and then we're also going to be converting the meters into miles. So 1 mile is approximately 1,609 meters. So if we set it up correctly, our labels are going to cross cancel, which they do. And then multiplying across the top, we actually end up with 5. And then on the bottom we have 1,609. And then dividing that out, we get approximately 0.0031 for miles. So 31/10,000ths of a mile. So we converted our distance into miles. Now we're going to, on step 2, we're going to convert the time into minutes, because again, we're looking at the number of miles in a certain amount of time, in this case minutes. We are given the initial rate of so much per second. So we're going to convert seconds into minutes. So that shouldn't be too bad. We have the fact that it was 1 second. We know that there are 60 seconds in 1 minute. And so we'd have 1/60th, which if we get the decimal form of this, it's going to be approximately 0.0167 minutes. So 167/10,000ths minutes is approximately what that ends up being. So what we're going to do next, so step 3, we're going to basically find a.k.a.'s speed in miles per minute. So distance equals rate multiplied by time, or rate is equal to, right, solving this equation for r, rate is equal to the distance divided by time. And so we're going to take the distance that we came up with in step 1, we're going to divide it by the time in step 2, and we end up with 0.1856. And again, this is a rate of miles per minute. So using this rate now, we can figure out, well, how far is a.k.a. running in 126.5 minutes? So to figure out that, we're going to take the rate we just calculated and multiply it by 126.5. And we end up with 23.5 miles, which is short of the goal distance of a marathon, right? So this means that a.k.a. is not going to be able to beat that record, because in that time, he's only running 23.5 miles. So we got 23.5 miles, and so my answer would be no, he's not going to beat that record. And that's it for using dimensional analysis to convert units. I hope that helps with that concept. Thanks for watching.